Good evening. My name is Kumarjit Ray. I am the chair of Computer Society SBC Student Branch Chapter under IEEE Kharagpur section. Here, under this SBC, we used to conduct different types of webinars, also physical events also. So these webinars, our focus is mainly to target audience across the world to discuss about the different domains like computer science and electronics, what type of work is going on across the world. To discuss about that, we used to conduct this type of webinars. So here in today's webinar, the title of the talk is Application of Machine Learning in Power Engineering, where we have invited Dr. S. Albert Alexander from VIT Valor Institute of Technology, from the Department of School of Electrical Engineering. So before starting the talk, I'd like to give a small introduction about Dr. S. Albert Alexander. So he is an uh, associate professor in the School of Electrical Engineering, PIT Fellow, and also former professor in the Department of Electrical and Electronics Engineering, Kongu Engineering College. And also he was also the postdoctoral research fellow from Northeastern University, Boston, USA. He has also got the Raman Research Fellowship from the government of India. His academic research experience is more than 18 years. He has lots of research publications, and his research mainly focuses on fault diagnostics in solar energy, smart grids, then AI-based controllers, power quality, and smart healthcare systems. He has published over 92 journal papers, which are published in the IEEE, IET, Elsevier, Springer, Wiley, etc. He has also published around 70 conference papers, which are presented at national and international platforms. He has also authored 9 books, which are published under CRC Press, Elsevier, Springer, etc. And the topics are on power electronics, AI, and electric vehicles. He has also guided 6 PhD scholars and also currently monitoring and supervised 32 graduate and postgraduate uh, uh, projects. So he has also like completed different research projects funded by government of different like government funded projects, like around 8 government funded projects he has completed, and whose total valuation around 2.3 crores. And he has also 2 ongoing projects funded by VIT and Ministry of Education. He's recognized for PhD research on power quality with a national award, that is IST. He is actively involved in global research collaboration in these domains. So he has got different awards, around 29 awards he has got, including Young Engineers Award, IEI, Young Scientist Award, that is SPRERI, and Best Researcher in IEEE Madras section. He is also the chairman of IEEE Power Electronics Society Madras section, and also a senior member in IEEE. He is the vice president of Energy Conservation Society India, and AICT Margadarshak Atal Innovation Mission Mentor, and AICT approved translator for engineering books. He has delivered over 300 plus invited talks across 9 Indian states and USA, and organized 13 faculty development programs and workshops and seminars. So throughout the careers, he has done many things. So we have tried to cover as much as possible, but as this is a very short introduction, so we have tried this only. So before starting, there is a short general instruction for all. Please keep yourself muted during the talk, and please wait till the end of the talk to ask any kind of question, as there will be a session for Q&A at the end of the session. And also an attendance sheet will be distributed, and please note your attendance there. And also, if you have any query and any issue in the middle, you can like type in the chat box. And also, we'll be taking a group screenshot of the event at the last. So please, at that time, you can turn on your camera. So thank you everyone for joining. So I would like to request Dr. Albert Alexander. You can start.
Okay, so thank you so much for the invitation. I hope I'm audible at my end. I'm audible, sir.
Yes, sir. You are audible, sir.
Okay, so thank you so much for the great invitation.
Yes, sir.
Okay, so on this invitation, I would like to give some inputs related to machine learning and its practical implementation procedures, especially for the application in power engineering. Normally, IEEE across the globe, it is a very interesting professional society which abides the ethics in research and promotes the culture of networking, and also it initiates and stimulates the collaboration among the peer researchers in the country and also the big oil. So very thanks for the IEEE Kharagpur section, Computer Science Society, for giving this opportunity. Best regards from IEEE Madras section. Before going to the machine learning, the people we talk about on the three different aspects of machine learning on AI, machine learning, and deep learning. I am the person from electrical domain, electrical and electronics domain, and this program is hosted by Computer Science Society, and I hope many people will be from computer science domain. But the primary developers of this AI and machine learning or deep learning, mostly, I'm not telling the 100%, mostly they are from the domain of electrical engineering. So the context of these three domains is very interesting. And also, I would like to explain how we can able to apply this task in a very simple manner. You will not believe me. You will not believe me. I used to develop a deep learning model in the MATLAB with just 5 lines of coding. Even I'm trying to reduce to 2 lines. That is possible because earlier, when I started this machine learning and deep learning models for my career, I used to write the lines and lines of coding. But now it was summarily reduced. So that has resulted in numerous publications, the area of machine learning and deep learning. Before we talk about on this learning, I used to give a small definition about what is meant by learning. Because a machine learning is concerned, we need to know what is meant by learning. Learning is defined as tuning, that's all. Many people will say that learning is knowledge sharing, learning is studying for the exam, learning is acquiring some knowledge. No, learning is called as tuning. Whenever you go some accreditations like NBA or NAC or ABAT ranking, they give the maximum priority for teaching learning process. Whatever you say or whatever you deliver, you consider that as a teaching. Then what is meant by learning? Okay. What is meant by learning? So I can see some chat box message. Okay, so smart sorry. So we talk about on the teaching learning. So teaching is a centric of the teacher. Many people will say that I am teaching with PPT, I am teaching with some innovations, I am using blended learning, I am using flipped learning, and I am using project-based learning. So everything you talk about on learning, what you deliver as an input, that is called as a teaching. So teaching is an input. Even here, what we're discussing, I'm teaching. Let us say I'm giving some input. But our primary focus is on the learning. That means what is meant by learning? Learning is called tuning. To understand the process of learning, we have to know about the basic biological inspiration. I will not take much time because everybody would have been known this biological inspiration. That is, whenever you want to study something or you want to know something, what you have to do, you are sending the signals inside to the nucleus. While the process of sending the signals inside to the nucleus, there will be a small gap will be available. That gap will be filled by the chemical substances like sodium, potassium, and chloride. So the signal X, it has to cross this barrier to reach the nucleus. If the barrier was remaining over here, what will happen? The X will remain as a, whatever you teach, it will remain only as a X. But what is learning? I want the X to reach to the nucleus of the students. So what I have to do as a teacher, I want to do the process of tuning this barrier. So the process of tuning the barrier is called learning. Whenever we study about the controller like a PID controller, we will be studying the mechanism of tuning like KP value, KD value, and KI values. You will be tuning these values to get the appropriate value of KP, KD, KI. So that is called as a tuning. Once you tune the PID controller, then the controller will work, obviously. Such kind of tuning is needed in the learning. That's the reason in the classroom, we are having some students, they are much excellent. We are having the students, they are average. They are having the student, they are poor. We cannot say that the excellent student is study well. We cannot say that the average student is studying moderately. We cannot say that the poor student in the studies is not at all studying. Whereas whatever the input teaching is common for all the three cadre of students. But why in the class we are having three grades? The process of tuning. The excellent student is tuned well, he moderately tuned well. Poor students is not at all allowing my synapses to tune well. So as a teacher, the role is not only to teach the students and also want to tune the synapses. So the process of tuning is called learning. So this is the biological way how the microscopic structure shows that whenever you think something, whenever you do something, or whenever you want to do any action, how the individual cell is wandering and how it is connected to another cell body and how the movement of cells in your central nervous system takes place. We want such kind of reaction. We want such kind of reaction to be taken care over this one. We want such kind of this action to be taken. If you keep it as an idle, without any movement, without anything, that means the learning process is not takes place. It is an hourly taken microscopic structure, how the neurons in the central nervous system, it combines with other neurons for solving the complex real world problems. Similarly, whenever we talk about machine learning, whenever you give a data, each and every data will strike like this, some kind of firing. Giving a single data, it refers to firing. So we got a beautiful word called firing. What is meant by firing? Whenever you give the data x1 and x2 to your system, the instant when you are sending this data x1 and x2, it got firing. So this scheme only, it is called as Hebbian rule. Hebbian rule refers that the firing takes place whenever you deliver the data. So each and every scientist, they made various algorithms in artificial intelligence and machine learning to solve the real-time problems. Now let us say how the learning takes place with a typical example. Let us say the problem statement is, the statement of the problem is, the mother wants the kid to eat of its own. That is a target. That's a problem statement. The problem statement is the mother, the mother wants the kid to, she wants the kid to eat the food of its on its own. That is the target. That's a problem statement. So the mother is giving the data. Let us say this is a data. Data number one, she is giving. So what is happening? This data is taken to the kid's central nervous system. The data is given. So while the data is given, what is happening? When the mother is giving the data, the children, what it does, it keeps the synapses very thick initially. So whatever the data given by the mother, it is not reaching the nucleus, or else if it reaches the nucleus only, the one neuron will interconnect to the another neuron. If it reaches the nucleus only, it will transfer to another neuron. So the X, it is not at all reaching my nucleus. Day number 2, the mother is giving the second input X1. The children not at all eating of its own. So like Xn, up to n number of data the mother is giving, okay, the kid is not eating. Okay, so the data set is given by the mother, but the kid is not eating. Okay, normally what we would say, this is called as my data set. This is a data set. The data set is created or generated by the mother, was given to the kids. The kid is not at all responding. Okay, what kid is saying? No, mommy, I will not eat of my own. You just feed me every day. I will not eat of my own. You please feed me every day. So whether for machine learning, whether data set alone is enough? No. So what the mother is doing, she is taking some steps to make the data set to reach the nucleus. What are the steps the mother is doing? First step, the mother starts to scold the kid. No, you have to eat. Second one, she even beat the kid. She will even compare the kids with others. See, that kid is eating, this kid is eating. Some mother will even cry to the kid, no, please eat. Some mother, what it will do, they will combine all the tasks together. So whatever the steps the mother taken to make the data set to reach the nucleus, the steps are called algorithms. So in the machine learning algorithm, you have a data, it should be supported with the algorithm to perform the task. So you can able to understand, if you want to perform a machine learning task in real time, the first thing you need a data. Second thing, you need an algorithm. And third step, you need the execution. That's all. Very simple 3 steps. Just as 3 steps. Whenever I'm teaching the subject to my students on machine learning, whenever you are having a data set in your hand, your work is 99.5% over. Your work is 99.5% over if you're having a data set in your hand. The remaining 0.5% is only writing the coding for algorithm and its relative testing for execution. That's all. What they are doing, they download the data from the Kaggle or from GitHub. They will download the data set and they will download the algorithm in another thing. They will combine this and take the results and publish. That is not a right procedure. I will never ever recommend any people, those who are working in the machine learning, go to internet, download from the Kaggle or from GitHub, and then download an algorithm and then mix these 2 algorithms and take the result. That is not the right procedure. And you can ask a question, sir, many people are doing like this. Even their research paper, they are putting the data availability statement. The data is available on request by the authors. Or else they specify the statement as data is available in the kaggle.com or data is available in the github.com. But I recommend the people, you generate the data, you produce the data. I will tell you 5 methods by which how you can able to create the data. Once you create the data, you know what is the diversions, the value takes place. You can able to set the boundary condition of your data, because the data which has been available on the internet, it will be taken for their environment, it is taken for their nomenclature, it is taken for their specifications. But your work is different. Many people will ask this question to me. Sir, I am working in the brain tumor reduction. I am not getting a data set from the hospitals for the brain tumor. So I am downloading from the internet and doing. You can do that one, but for study purpose. But not for publishing, not for completing your degree. If you want the brain tumor data set, you approach the doctor. Get the real-time data. Get the unlabeled data. You get the unlabeled data. Use your algorithm. So your focus point will be on the algorithm. So I will tell you what are the 5 steps which I normally use for the collection of data set. Step number 1. I will normally simulate my system in the MATLAB or in the LabVIEW by varying the parameters at the input end or the output end. I will collect the data set. Simulation studies. For example, my work is completely on the inverter fabrication. We are working on application of machine learning for inverter. I will share the work to you, what work we are doing for machine learning for inverter to figure out the faults and also to improve the performance of the inverter we are doing. So what the inverter which I'm doing, I simulate in the MATLAB by varying the input voltage or the load variations. I simulate for the different conditions and I generate the data set. Okay. Second one, sir, I don't know to simulate. What to do? Option is there. You go for experimental setup of a simple prototype. Collect the data. What work you are going to focus, you make as a small experimental prototype, vary the parameters with help of a rheostat, with help of your auto transformer. You vary the value, or when you vary the load decay resistance box, you vary the value, collect the data sets. Sorry, sir, I don't want to go for simulation. I don't want to go for experimentation. From where I will go to get the data? The third is MM. MM stands for mathematical modeling. For example, whenever you study mathematics, your maths teacher will give a problem like this. X square plus 7xy plus 9y square. A problem. But we take this as a problem. But you should understand that this problem, it represents a system. Normally, a system is there. Given you consider a human body is a system, this human body is now converted into an equation format that is called mathematical modeling. Normally, a control system engineer, what is the role of a control system engineer? I will give you a physical system. Let us say that I'm giving an electrical vehicle to him. What he will do with the electrical vehicle? He has to convert the electrical vehicle in the form of a mathematical equation. That is, I call as a G of S is equal to C of S by R of S, a transfer function. The output by input a mathematical equation like this. And then my EV is now represented in the form of an equation. So now you got an equation like a mathematical modeling. By varying the parameters in the mathematical modeling, you collect the data. For an example, you substitute x values as 1. You calculate what is the value of your f of x. X is equal to 2. Calculate f of x. Calculate the f dash of x. So you can cook the data of your own. You should know that, mathematical modeling is the first step for the creation of your digital twin technology. Maybe in our next lecture, I will be explaining you about on digital twin. For digital twin, you have to know about the basics of mathematical model. That is the reason whenever the people those who are studying the control system, they will study the mathematical modeling of electrical system, mechanical system, and electromechanical system, rotational system, translational system. Why they studying all these things? In order to convert a physical system into a mathematical equation. Sorry, sir, I'm not interested to go for mathematical modeling. What is the other procedure available to collect the data set? Available. The fourth one is by creating a formula for your system. Formula for your proposed work. For an example, if you're working with a windmill, how to create a formula for windmill? We know that the windmill works basically on the kinetic energy. Kinetic energy is given by half mv square. So mass I substitute as half into air density rho into v square. So the energy equation of the windmill is given by half into rho into v cube. And you can even add the area of cross section of your blade, crest factor. So a physical windmill, now we can able to convert in the form of an equation, formula. So by varying the value of your velocity, by varying the value of your area, you can able to get the energy data. Sorry, sir, I'm not interested in this one. So what is the other procedure we can able to do for this particular thing? You can able to make with a question array. So question array is one of the important aspects where you can able to see what is the mechanism which we are going to get the corresponding results. So with this particular thing, you can able to understand. Okay, so the things what we do is a very important thing. Okay, so where we can able to understand that so many ways are available to cook up the data and to generate the data. Okay, not by just downloading the data. I normally use for all the paper publications which I made for IEEE transactions that has been published in IEEE transactions on energy conversion and IEEE transaction on dielectrics. So these papers I use this technology, not downloaded from the internet. So as I already mentioned you, the first step for any machine learning implementation is going to be the data set. If you're having the data set in your hand, 99.5% work is over. The next one is choice of algorithms. I will tell you how to make a choice of algorithms. There are so many algorithms are available. To name a few, I can say regression, support vector machine, Markov design process, backpropagation, perceptron, Adeline, Cohenheim, learning vector quantization, okay, adaptive resonance theory, SARSA, Q-learning, any kind of algorithms. So we can able to apply any algorithm depending upon the nature of your work. If you are working on the classification problem, you go with certain algorithms. You're going with a forecasting problem, you go with the algorithms. You go if you want to make with another set of things like a prediction, classification, analysis, you can choose any set of algorithms. Nobody can say that you have to go choose this algorithm, you have to choose this algorithm. No one can make any algorithm. And meanwhile, don't compare any algorithms. These algorithms are not working in the competitive manner. The algorithms are working in the complementary nature. I cannot say that support vector machines are better than backpropagation. I cannot say that SARSA is better than Q-learning. I cannot say that. For my application, for this environment, for this available data set or that particular environment, SARSA gives a better results. Whereas the same research problem, you have been working for the different domain, different area, different specification. So some other algorithm will work. So how will you compare these two algorithms? The algorithms can be compared with the terms called CC. What is CC? CC refers to computational complexity. Computational complexity means the time taken by the algorithm to perform your task, to complete your task. In addition to the computational complexity, the algorithm also has to give good precision, good accuracy, and good F1 score. These are the performance parameters of algorithm. I want to compare the algorithm with respect to these 4 parameters. So this is one simple example to understand the typical nature, how we are going to create a network to distinguish that image. For an example, this is the input image. So in the input image, I'm going to extract the futures. This process is called future extraction. What are the futures I'm extracting? I'm extracting the color. I'm extracting the intensity. And I'm extracting the other any future samples I'm extracting. Let us say these samples are X1, X2, and X3. The futures are extracted. For an example, if you are working with a convolutional neural network, this convolutional neural network speaks only on future extraction. How will you extract the futures from the given image? CNN is not an algorithm. Again, I'm telling you, convolutional neural network is not an algorithm. It's only a pre-processing process. Pre-processing stage is the convolutional algorithm, convolutional neural network. At the end of the convolutional neural network, you are getting some A. This A only you are giving to an algorithm. After then only you are using the algorithm. So you cannot say that CNN is an algorithm. CNN is a process. We have to distinguish the terminologies. What is a process? What is a technique? What is an algorithm? Many people are having a confusion that process, the term as algorithm. Techniques, the term as algorithm. Algorithm is totally different. Process is the way how you are structuring the data sets. Techniques are how you uplifting or upgrading the data set before you allowing into the war of machine learning. Before you apply the war of machine learning, what are the steps you are going to take? So the input, I have taken some parameters. Of this, let us say that I'm taking the parameters of dog. But these parameters, sometimes it will match the parameters of cat or it will match the parameters of fox. Now what will happen? Okay, now this particular process, what I'm showing here, this is I'm testing. It is not a training. Training is different. Testing is different. What are the process involved in the training? Training process involves the data sets. As I already mentioned you are having some 1,000 data. Based upon the data, you develop to the model. Let us say that this is your model. The model is a black box. Using the available data set, you created a model. That is, you trained the model for the customers. You have delivered this particular model. Now you want to test the model. Now what is happening? You are giving the test image. That is, I'm going to give the image as X. You are giving the image as X to the model. Now what the model has to do? Receive the X and it has to give the answer. What is this X? That is called machine learning. In simple, I can define the machine learning as for training, you use the data. These data are the present value or else a past value. That is the data you are going to use. You're not going to use the future data. For example, present data means you're using the data you have taken in 28th of February. Past data, you have taken 26th of February. You have taken the data. Using this data, you developed this model. Now, the 1st of March, that is tomorrow, you're going to test with an image. And you're going to say whether the image is dog or cat. So in simple, I can define machine learning as using the past data and the present data, you're going to predict the future samples. That is called machine learning. That is called machine learning. What many people they're doing for their publications, they are taking the data set. We don't know whether they're taken the past value or whatever. They're also testing the machine learning with the past value. How can it work with you? You have to check with your futuristic value. You have to predict the things. What is happening today? For an example, you consider the same example with the help of a doctor. So I'm developed a machine learning model and given to the doctor to detect the brain tumor. Now the model is ready. So I collected the 100 past samples from a doctor, okay, or else I generated the samples by visiting the doctor hospitals and collected the 100 sample and I developed this model. After checking this performances like complexity, effort score, precision, and accuracy, I deliver this model to the doctor. Now, today, I delivered this model yesterday. Now the doctor is using this model. Today, let us say now the time is 6:40 p.m. Now this particular time, one patient is coming. Now the doctor, it allows this particular patient image to the particular model and he can able to see whether this patient is having brain tumor or not. That's all. So the model I created with the present data and the past data in order to predict the futuristic thing, whether is having the thing. That's called the machine learning. So we can say that the input is this one. In the output, it will show whether you're having this cancer or not, tumor or not. As per this example, it will show whether the image is dog or cat. So we know about the input, we know about the output. What is called as the hidden? What is defined as hidden? Hidden means, something is hiding. Why we require hidden? Hiddens are required for solving the complex problems. Whenever your problem is quite complex, which cannot be able to solve with the input and output alone. If you're using with the input and output, that network we normally call as a perceptron. Perceptron is also called as a single layer network. Whenever you're counting the layer, you should not count input. You have to count only the output alone. When you're having only the output, it is called as a single layer network. Single layer network is called as a perceptron. So single layer network can be used to solve the problems like logic gates. Simple linear problems can be solved by perceptron. But a complex problems like this, you have to go for the multi-layer networks. Multi-layer consisting of input, output. In addition to that, I'm having some hidden. So let us take the input x1. This x1 will reach to the input of my hidden. Okay. And then the hidden processes this along with the samples it receives from x2 and x3. And then it gives the output to get the decision statement. For an example, if you're adding more number of hiddens, and the problem is much more complex, adding more number of hiddens, then I consider that as a deep learning. How will you create a deep learning? Input is there, output is there. Create the number of hidden layers, more number of hidden layers. Then it is called deep learning. That's all. Now, when we talk about the history of this AI and the neural systems, it was started in the year of 1943, where these Becklow and Pitts, they presented a paper on the conference on simple logic gates, a toy level problem. How they made the training of a simple AND gate. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. They trained the system. And then Hebbian network, he came. Hebbian means, so whenever you fire the input X1 and X2, firing takes place. When the firing takes place, the weights are tuned. That's called Hebbian. Rosenwald, the perceptron he developed. What is perceptron? It is called as a single layer network, which having the input and also your output. And next in the 1960, they developed the Adaline algorithm. What is Adaline? It is called as the adaptive linear element. Basically, he used a simple Ohm's law for developing this algorithm. What is Ohm's law? Ohm's law states that voltage is equal to Ri. You should not say V is equal to IR. That is wrong. V is equal to R into I. That's called Ohm's law. So he has taken the voltage as an input and the current at the load. Okay, and then we can able to see that he can able to vary the value of resistor. This concept he used in Adaline, where the input is taken as the input data, either a numerical data or image data, you taken the input, and output is a decision. Based upon that, he tuned the weights. The tuning of weights, as I said, that tuning of weights, a tuning is called as the learning. As how the resistor value is tuned, you tune the value of weights. That is called Adaline. So in 1969, they developed one more paper on the perceptron for generalization, ability of the perceptron. And they found that, this perceptron cannot able to solve the problem of XOR gate, because XOR gate is not a linearly separable problem, and say that ability. Okay. So that is called the limitation. They inform the limitation of the perceptron. You can able to solve only the normal AND gate or gate, kind of, not XOR gate. 1972, they developed the coherent self-organizing future maps. In 86, they developed the back propagation. And then they developed the radial basis function network. This is a very interesting algorithm. BPN and the RBFN. Very, very basic. See, all these algorithms, whatever I'm stating here, they are changing in only one aspect only. Giving the input, giving the output, all the algorithms are same. The way how the tuning occurs, based upon the tuning, the algorithm differs. The way how the tuning takes place. As I said, perceptron, the tuning takes place in a different way. How? For an example, based upon the output side, I will check the parameter. So where that summation of xi, wi is greater than or equal to 0, I give 1. Otherwise, you give 0. That is called perceptron. Adaline, it's something like an Ohm's law. Back propagation algorithm, that is very simple, I will tell you. Okay. So when we talk about so these are the list of algorithms. I listed only the sample algorithms. So unsupervised algorithms are where when you are working with unlabeled networks. For example, I'm giving some data and I'm labeling as voltage. So you know the voltage, these are the value. I'm giving a data set, but it's not labeled. So unlabeled data set is also called as unsupervised learning. Or unsupervised learning is also called as where you don't have any targets. You're having only the inputs. Based upon the inputs, you're going to work with. So I recommend the researchers, those who are working with the machine learning, you work with any kind of research problem and apply all the algorithms and make a comparative analysis. That will be a very interesting paper. We could make many papers onto that. Okay. And then supervised learning. What is my favorite? Okay, these are some of the supervised learning networks. I listed only the few which are my interesting choices. So the first algorithm, what we talk about is on the perceptron learning algorithm. You can able to see, I'm going to give a set of inputs along with a bias. It was summed up, and I'm using an activation function, and I'm getting some results. For example, you're getting the result as of 5. For example, you're checking that the answer is 5 is greater than 0. So that means it will be equal to 1. If you're getting the value something like -1 or -4, it will be result in -1. It's a perceptron. So you're going to keep a threshold. So this is called as a threshold. You're going to fix it over here. So as I already mentioned you, the tuning. For an example, this is you can able to see these are the sum of inputs and these are the initial weights. Let us say that I'm going to keep the targets, okay, as 0. I want the output to be 0. I'm keeping the target is equal to 0. Target is equal to 0. Okay, so I want to, this is the initial weights. Okay, so I want to calculate what is the output I'm getting over here. How to do that? 1.0 into 0.5 plus 0 into 0.2 plus 1.0 into 0.8 and keeping as 1.3. As per the perceptron, let us say that you're keeping the threshold theta is equal to 1.2. Okay, let us say that this 1.3 is greater than 1.2. So you are assigning the value as 1. You assign the value as 1 because you kept the threshold as 1.2 and you got the answer as 1.3. Since the 1.3 is greater than 1.2, you're giving the answer as 1. But you want 0, not 1. So what you have to do? You have to tune these weights. So the perceptual learning network, they frame the algorithm. That's a formula for finding the weights. So new weight will be equal to what is the old weight plus the learning rate. What is your requirement? I want the design is equal to 0. What you are getting, the output, you are getting the output is equal to 1 multiplied by your input. So based upon that, you can able to get the new weights. Again, the process will take place until you get the output is equal to 0. This is how the simple perceptron works. Now, I will share the presentation later because now I will tell you how the backpropagation algorithm works. So for the next 10 to 15 minutes, I will tell you some nuances about the different algorithms. So let us see how the backpropagation algorithm works. Let us say that I'm having the 3 inputs and these are my hidden and this is my output. Okay. Let us say that I'm just calculating the feed forward over each and every way and I'm collectively getting some output. Let us say that my output is equal to 5. I'm getting the output is equal to 5, but I want the output is equal to 7. What this backpropagation will do? I want 7, but I'm getting 5. So what it will do? It will calculate the error. What is the error? Error is equal to you want 7 minus you're getting 5. Error is equal to 2. Now this error function will propagate backside. Propagate backside. On propagate backside, it will give an additional thing called delta. Okay. It will give the additional thing of delta when it was traveling back. And again, from here also here it will travel back to provide a function called delta, which was influenced by the error function. Now, as I said that all the algorithms are varied by the nature of finding the weights. Now, how the new weights are calculated in the backpropagation algorithm? The new weights are calculated by what is your old weight plus what is your delta value. You'll be getting the new weights. That's all. That is called backpropagation. So I have solved one simple problem with the help of this backpropagation, and I've shown you that how the weight updation takes place. So I'll be getting the delta value in the reverse sample. So while updating the weights, the new weight will be equal to what is your old weight plus delta. You will get the updation of weights. Finally, the new weights is called as the backpropagation. Now I tell you about a convolutional neural network. Okay. As I said that it is not an algorithm. It is only a future extraction. I will tell you with the help of one simple thing. So CNN means, for an example, you are having an input. What is meant by convolution? Convolution means convolute. For an example, if you're having two signals like x1 and x2, convolution means x1 and x2. This is called convolution. I need two things for convolute. Finally, I want to get one output. How I'm going to get the convolution? Here you can see that this the image is the x1, and this kernel is also called as a filter image, that is called x2. So now this x1 or x2 are convoluted. In the process of convolution, we call that as a pooling. That's a pooling process. Pooling means, how the kernel it was represented in the form of some additional samples. We can see how the pooling differs. I will show one actual pooling. Finally, so it goes to the process. So this is the future extraction. So convolution neural networks means it is also called a future extraction. I normally call it the future maps. So here I missed to add one thing. It will go to pooling, and also it goes to the process called padding, and finally it comes to the process called flattening. Three process: pooling, padding, flattening of the convoluted image. Why it got the name as convolution? Because it convolutes my main image with a kernel. Once you get the flattened layer, now you apply an algorithm. You can use a back propagation over here, what we discussed. This will act as your input layer. This is your hidden one, hidden two, and output. Okay. Now, whenever you're adding the two hidden, it is called as your deep learning. And finally, you can use an activation function called a softmax, which will give your value between 0 to 1, and then you can be able to have a probabilistic distribution. You can classify the images. Okay, whatever the images you are sending, you can classify as a horse, zebra, or dog. That's called classification. You see how simple the convolution. I will tell you, there's a process in the convolution neural networks. You are getting the input. Input means your image and kernel. These two are convoluted. Pooling, future map. Okay, and then you are making the softmax, finally getting out. That's all. CNN. Okay, so let us say that I'm having, this is the image 5 cross 5. You're having a kernel 3 cross 3. What I have to do? You have to place the kernel in this image. How we are placing? You can see that I placed this kernel over here. I placed the kernel over here. What happened? 3 multiplied by 0 plus 3 multiplied by 1 plus 2 multiplied by 2 plus 0 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 0 plus 3 multiplied by 0 plus 1 multiplied by 1 plus 2 multiplied by 2. You got the answer as 12. Similarly, you place this kernel here. Here, you will get the answer 12. Similarly, you place the kernel over here. You will get the answer as 17. You place the kernel here, kernel here, kernel here. Like this is the future map. This is called convolution. You convoluted the input and kernel. You got the future. This is the process of convolution. So this is a process of convolution, what I explained you now. So this is the original image, your kernel, you convoluted, how the calculation takes place, how you are getting the values for. Just now I explained. This is an animation to show for the how the values we are getting for the convolution. You see how CNN is very simple. When you want to write a research paper on CNN, you take your image and put a kernel. That's all. So this is for the RGB image, for red, green, blue. This animation will show you how we are getting the final value over here for each and every calculation. This is a kernel for R, kernel for next, kernel for this one. So moving off this kernel. Now I want to talk about on stride. What is meant by stride? Stride means, let us say that I'm going to use a 2 stride. So what is meant by 2 stride? 2 stride means, for an example, you are using this kernel for the main image. Okay, now I'm going to use a stride is equal to 2. So initially you started your action over here and kept the kernel here. Stride 1 means you will start over here. Stride 2 means you will start your kernel here. So keeping this, you got the answer. Keeping this, you got the answer. Similarly over here, after stride 2, it will be there. So you can be able to get the minimized thing. You can work with stride 1, stride 2, or a number of strides. What is meant by padding? Padding means, I want to eliminate the effect of bordering. So you can able to see that this is the original image. I'm going to pad my image by the bordering with the help of my zeros. Now what will happen? I'm placing the thing. What is the reason of this bordering effect? So bordering effect will occur whenever we are changing the pixels movement. Okay. So I want to overcome the bordering problem. So the bordering problem that we normally call as the edge problem. So edge problem, because sometimes what will happen, what are the images over there, the edges has been a possibility to be get overhidden. So I want to use the padding with help of 0. So it's a uniform padding, and then I want to apply the CNN. So it's a padding, the overall diagram. So pooling, so similar to the conventional pooling, what we already been discussed. Okay, so pooling is classified into 2 types. So once you made the pooling, so pooling I already mentioned you how the pooling takes place with the help of the strides. Pooling are classified into 2 types. One is called maximum pooling or average pooling. If you take a matrix like this, out of these things, this is a maximum. You take this. Here, this is maximum. Here, this is maximum. Here, this is maximum. So it's called maximum pooling. Average pooling means you add the 4, divide by 4, you get this value, average pooling. It's a pooling factor. Finally, we get the flattening and get the thing. So why we are going for a CNN means, okay, your image may be of your size of 39 cross 39. Next, with the pooling and process, it will reduce to 37 cross 37, and then 17 cross 17, and finally it goes to the final stage of your network. Recurrent neural network. It is also one of the very interesting thing. Recurrent means I'm going to use the process of memory states. Okay, so whenever I'm having this input, I'm having this output. So let us say that I want to take care of this here. There is memory as well. So that is called the recurrent neural network. So we used to saw that will be useful for sentiment classification, image classification, and language translations. And it is very interesting one. So here only we talk about on LSTM. Why I using this LSTM means I had made one paper for forecasting of the solar PV generation. Okay, solar PV generation we went with the LSTM. So LSTM is the basic structure of LSTM is given over here. That is, this LSTM, it is advanced type of recurrent neural network. So it is having the layer of CAN H. It is having the 4 interacting thing. So this structure will help us for the long-term memory. I want to forecast the solar PV system for India. So I need more number of memory. What is the PV generation December? So that cannot be solved with a normal machine learning models. I want to go for the LSTM. So LSTM networks you can able to see when you talk about on the normal recurrent neural network, it's having a basic structure. It consisting of a layer, and a tan H layer, where these are called as my input, present input, previous input, and the next input. So, and this basic recurrent neural network, it has some memory. That's called memory problem. Limitations, it suffers from short memory. So I want to take a long period of information. That is the reason many people, those who are working for the forecasting, they are working with the LSTM models. So for that purpose, we need to know about what is meant by recurrent neural network. So the recurrent neural network, how it works, you can see I'm having an input. This seems to be the middle layer. Okay, so here the middle layer consists, this is a very important thing in the middle layer. Middle layer consisting of multiple hidden layers. That is called the deep learning. Multiple hidden layers, each will have its own activation function, weights and biases. So the recurrent neural network, they use the backpropagation. That's the reason backpropagation is the basic algorithm, whereas this RNN and CNN, they're using it one. So you cannot say that RNN and CNN are an algorithm. They are all a process. They are all a process which will solve your unique problem statements. That's what listed over here. This is the animation. You can see how the LSTM works. How whenever you talk about on the individual inputs, how each and every stage, each and every memory, it was taken into consideration, and finally it produces the output. Finally, it gives the output h of t in the top and bottom. So whenever you give as a multiple things, it having the function of this activation sigma functions and also tanh function. At each and every instant, it checks its memory. It checks its memory and finally it gives a thing. Instead of over flooding of the data at each and every instant, it makes the operation of the product and finally it provides you the LSTM. So using the LSTM, we normally solve some numerical problems in the LSTM. So for the time, I cannot able to do that for the sake of time. I will share. So we normally solve the problem for the recurrent networks to make the people to understand about the recurrent networks, and also about we solve some examples. And the GRU, it's also an animated one. Okay. So this is what my thing. If you have any discussions or questions, you can able to ask me. You can able to understand. I'm concluding at the slide number 120, but my slide is 252. Okay. So after this, I'm having the presentation on the machine learning and its cycle. We talk about on various algorithms on naive Bayes, support vector machines, decision trees, and the random forest, and our k-means clustering, support vector machines. Okay, but for the any other occasion, I will explain the part number 2. So as of today, we have completed the part 1 of my talk. Part 2 will complete later because I want to stick on to the time. If you have any queries, you can discuss now.
So thank you, Dr. S. Albert Alexander. So it was an amazing talk, and also I personally enjoyed this session, and we got really valuable insights about the introduction of machine learning. So I'd like to request all the participants, if they have any question, they can ask directly, or also they can type in the chat box.
Good evening, sir. Your session was really amazing, and you gave very good insight about machine learning.
Thank you.
Now, my curiosity is related to Gen AI. So, how do you
Okay.
relate this concept with Gen AI, and how the models in Gen AI differ with the models that are existing in machine learning, sir?
Ma'am, actually, in the today presentation,
Huh.
okay, so I have not even touched up the basics of machine learning. So
Correct.
I have talked only about the basics. What is the prerequisite of machine learning? Normally, the
Yes.
machine learning works will start from your regression concepts, kind of. Okay,
Okay, sir.
but Gen AI is, the normal machine learning. For example, you take a regression. You want to predict the price of a plot in Chennai. Okay, so you know what is the price it has been sold in the previous year or this year. You want to predict what will be the price of the particular plot after 5 to 10 years. You can able to do
Yes,
that. But the Gen AI, what it will do, it will create some content
sir.
based upon your data. It will create some content. It will create some videos. It will create some text. For an example, if you're really interested to write some books, Gen AI will be the option. So you can give whatever thing you need to do as an hints development. So this Gen AI will receive it as an input. It will club together and will give you as a complete text.
Okay. Sir, again, see, in machine learning, we need to have a pre-trained data set. Okay, sir.
Yes, obviously, yes.
Yeah. So, Gen AI, what kind of data set it actually requires, and what are the different models that are available? See, we want a different kind of inputs, like it could be video, image, text, and so on. So
Yes.
what models really support uh, related to the data? So it's just, even I'm a fresher, so
Okay.
it was just my curiosity to get the information from you, sir.
Ma'am, actually, I need to tell one very important thing. That is a very basic thing I want to tell you for the benefit of all the participants. In every engineering colleges, there is one course available that is called information technology, where the people they study called BTech IT. Again, in the same
Yes, sir.
institute, they're having one more course that speaks on BTech data science. Okay, but obviously you should
Yes, sir.
understand that
Yes, sir.
data is called as information. So the
Yes.
IT people, those who are studying the information technology, they are studying only on the data. Data is just an information. So as per your question, what type of data you can give the information in any form? Either it may be a numerical data, discrete data, continuous data, image data, or else a video data, any kind of input that is needed for Gen AI. Based upon that, it will figure out what is the requirement at the output end.
Okay, okay, sir. So we don't have any specific models as such which works for specific type of
No,
datas.
no, ma'am. It's a Gen AI is a
Okay,
common. It's as like a machine learning right now. So we can
okay,
make use of any set of algorithms.
okay, okay, sir. Okay, sir. Yes, sir. Thank you, sir. Thank you, sir.
Thank you, ma'am. And I can
Thank you, sir.
find some questions in the chat box. Okay, so I can go by one. So, what are the biggest challenges in applying in? So there is no challenge, as according to me, if because the challenge is only on the data set. Other than, as I already mentioned, maybe we will conduct one more program where I will explain the 5 lines of coding to everyone, where you can able to understand. No, because you should understand that I skipped taking BTech computer science because I don't like coding. I don't like coding. That is the reason I took electrical engineering. But now the curiosity of coding makes me to be knowing more on AML. I wrote 2 books on AML, which is by Elsevier and also in the CRC Press. Presently, I'm writing one book for Wiley. It will be released at the end of 2025 on basically on AI and ML. So, because the person who hates the coding, but here the biggest challenge is data set. Once you get the data set, your work is just 0.5%. We want to do much more effort for the 99.5%. That's what many people will ask me, sir, you develop so many optimization algorithms. What is the challenge? I say that, by formulating the objective function, if you formulated that, your work is 99.9%. The remaining writing coding is just 0.1%. The challenge is just on data. Okay. And Jinesh Bhatia, sir, he was, thank you, sir. Can you share it for understand? Yes, sir, I will share the presentation. What process suitable for power consumption data? So which process? So actually, I am doing one project on this where using the machine learning models, I want to forecast the solar PV generation. So generation is totally different. And your question is not on generation. Your question is on the power consumption data. So you, for an example, the process means, you have to check whether you're going to do your work in industry or residential. If it is the industry, what is your loads? What are the consumption pattern of the loads? What is the maximum current settings of the loads? What is the variation of the current settings? So based upon that, you can able to predict. If your loads are consuming the current in this way, what it will be your electricity bill for the next month or next year? What will be the analysis? And based upon the power consumption, you can also make the fault tolerance system, fault in your power system, and grid interactive studies and grid analysis can be done. Is there any minimum number of data required? So it's a very, very, very interesting and important question, sir. How many data are required? Some people will say that, sir, I am having 5,000 data. So my work is perfect. I tell you one secret. Even if you have 10 data, you can work with a machine learning model. 10 data with useful information, that is enough. Rather than going for 5,000 data that was poorly downloaded from internet, which does not bears any useful thoughts, it is waste. So because I worked only with initially I worked with 50 data, then 100 data, and IEEE transaction paper, we worked with only on 1,500 data. That's all. what we have made that one. Because you should understand that these are called as a smart systems. These are called as a intelligent systems. I will define the smart system and intelligent system with one small story. I'll take just 2 minutes. What is meant by smart system? One day, one fine day, I have taken my son to temple. On going to temple, I have given some inputs to my son. Okay, so that is, you should be you should be very always with your parents. Okay, and you should not touch others' belongings. Kind of. So I have given some kind of inputs to my son. So some 2 to 3 inputs I have given to my son. And next day,